Before we begin Chapter 10, we have to review something that we've seen before called completing the square. So we're going to start by looking at some squares here and then look at the algebra that goes along with it to help us get an idea for this. When we have a square, and we're going to call this length 9, and if you have an unknown length, we're going to call it x, we want to label the area inside of this larger square. So since this length is 9, we can assume that anything on this side is symmetric, so this is also 9 and that this is also x, because they're squares. Since this is 9 and 9, this area inside of here has an area of 81. Since this distance here is x and this distance here is x, this larger square has an area of x squared. And when we have this rectangular shape down here, because it has a length of x and a height of 9, it's 9x. And this one is symmetrical, so it's also 9x. So the area of this entire square could be given as x squared plus 9x plus 9x plus 81, just by looking at the different pieces. Also, though, look at the length of this entire square, like the whole length. It has a length of x plus 9. So we could also say that the area of this square is x plus 9 times the other length, x plus 9, or x plus 9 squared. If we FOIL this out, x plus 9 times x plus 9, we will get x squared, 9x, 9x, and 81. We get the same thing, whether we're looking at the little pieces or the larger side. Typically, we write this as x squared plus 18x plus 81, just to simplify it a little bit. So let's go ahead and let's label these other squares following the same procedure. We want to make sure that we highlight the area of each of these sections, and we're going to say, what could we write as a binomial squared? How could we talk about the entire length squared? So since this is 8x, we know that this side here must be 8, which means that this square is 64, 8 by 8. That also means that this longer part here would be x, and since this is symmetrical, this would also be x. So there's 8x. And that means that this bigger square is our x squared. So we have x plus 8 as the side. X plus 8 squared gives us x squared, 8x, 8x, 64. Or x squared, add these two pieces together, 16x plus 64. Those are all equivalent statements. Next one. We have an x and a 12. So this part here being 12, we know that this is 144. This part here being our x, we know that this is 12x. It's symmetric. And then this will be our x squared. So in our binomial, we have x plus 12 quantity squared, or x squared plus 24x plus 144. All right, so what if instead I give you the equation to start with? So I give you something like this, and we have to try to label the square. So let's say we start with x squared plus 10x plus 25. Can we fill in the different pieces? Well, the 25 means this little piece right down here. And we know the x squared is this piece here. So thinking about this square, what must this length be? This must be a length of 5. And if that's true, then that means this is 5x and this is 5x. So when we're looking at the 10x, it had to split into two pieces. It had to be 5x and 5x to get these two right here. When we try to write the binomial for this section, so what is the total length squared? We say it's x plus 5, this little section right down here, x plus 5 squared. All right, what if we have x squared plus 6x plus 7? Again, we know that the x squared comes up here. We now know that the 6x has to split into 2, so it's going to be a 3x and a 3x to split evenly. But then we run into a problem, because we're told that we have 7. But looking at the edges of these boxes here, this must be 3 and this must be 3. So it needs to be 9. Needs to be 9, but we only have 7. So what this is saying is that we have like this much area of that total square. That's the 7. We're missing this little corner. So in order to complete the square, we would have to add plus 2 to complete the square. And we'll talk about this as we start our lesson today. Completing the square means what do you need to fill in any missing gaps. Another way to look at it is if I give you x squared plus, let's say, 8x plus what? What must go in to complete the square? So we know that this is x squared. We know that the 8x splits into 4x and 4x. So we'll say the missing piece must be 16. That's what would complete the square. So if we flip over to our other packet of notes, we're actually going to skip down to the middle here where it says complete the square. And that's what we're starting with right here. We're starting with what numbers would complete this. So we're looking at the 20. We know it has to split. And then if it splits into 10 and 10, again, think about this, 10x and 10x, in this lower backhand corner would be 100. That's our missing number. So we want to look at the rule that we keep using. And the rule is this. You look at your middle number, and you take half, so you split it, and then you square that number. That's what we just highlighted. You split the b and square it. So half of 20 is 10, squared is 100. With 7 here, we have 7 divided by 2 is 3.5, and then we square that, and we get 12.25. So the missing number is 12.25. Now, we also want to be able to write these as parentheses squared. So again, think about this picture here. What do we need? We'd have x plus that length of 10. So it's not 20, it's not 100, it's the half. Same thing over here for the 7. We'd say x plus half of the 7, which is what you see up here. It's just the half of the b's when we write it with parentheses. So that process is the completing the square process. We're going to use it to help us when we're solving equations. So go to your next page. So for this one, we're going to put in a box, x squared plus 8x plus box. And then I'm also going to put a box on this side because whatever you add to one side of your equation, you must add to the other side of your equation. I want to take half of my 8, so 8 divided by 2, and then square it. So that's 4, squared is 16 to both sides. And now this can be written as a perfect binomial. So x plus 4 squared equals 16. My goal is to get to x. So I'm going to square root to undo that squared, plus or minus here, which gives me x plus 4 equals plus or minus square root of 16 is also 4. Going to subtract 4 from both sides. Make sure you slip that in front of your plus minus. So this x equals negative 4 plus or minus 4. And because there's two answers here, I want to find what both of them are. X is negative 4 plus 4, which is 0, and x is negative 4 minus 4, which is negative 8. All right, next one. There's already a number here on the other side, but that's okay. X squared minus 2x plus box equals 7 plus box. I need to take half of negative 2 and square it. So half is negative 1, squared is positive 1. Now I can write this as a perfect binomial. So it's x minus 1 quantity squared equals 8. Square root both sides, plus or minus. So x minus 1 equals plus or minus 2 root 2. Add 1 to both sides. So x equals 1 plus or minus 2 root 2. Now this also represents two answers, but since I know that I cannot combine a normal integer with a square root, you can leave it like this. That's fine. Last type of example you need to see is when you have the number on this side right here, you just move it over so that you can create a space for your box. When it moves over, it becomes a negative 41, and a box on this side as well. Half of negative 8 is negative 4, squared is 16. So I have x minus 4 quantity squared equals negative 25. Now when you take the square root, can you see it coming? X minus 4 equals plus or minus, there's a negative under here. So that means that we're going to need 5i. Remember, those i's are imaginary numbers when you have a negative under your square root. Going to add 4 to both sides. So x equals positive 4 plus or minus 5i. And there you go.